Hey everybody, welcome to Shop Talk with Bob and Keith, and I'm Keith, and I'm here with my best friend Bob.
Hey guys, I'm here with my best friend Keith, and what are we talking about today?
I have no idea.
Well,
I was kidding. I had it written down, and I memorized it.
Okay.
We are talking about speeds and feeds.
Yes, we are.
One of the issues that we hear from customers, they're having concerns with getting good, I can't think of the way to say it.
Quality cut?
Well, yeah,
Accurate
but
cut?
quality cut you get when you go to a butcher who knows what he's doing. I mean, you're running your machine, and you're not. Things are not turning out the way you want them to do.
Yeah.
You're burning stuff up, or you're breaking bits, or you're not getting accurate cuts, that kind of thing.
Yeah, that's all to do with speeds and feeds.
Yeah, and so we're going to talk about that a little bit, and you got two words, speed and feed, and outside of the fact that they rhyme, and I kind of like that.
It does. Speeds and feeds.
What's the difference, or what are they?
Well, first of all, I got to let everybody know that I am not an expert in speeds and feeds.
Why did I ask you that?
That's a good question.
Okay.
But I mean, there's a lot of customers that are going to be watching this that are going to know way more about it, have more experience with this than I do. But I know the definitions and I can do the math, so you'd think that I'd be able to get it pretty soon. And I'm learning. So speeds and feeds. So let's start with speeds. For our machines, that's really the RPM, right? So we really, for the E3 and the E4, have feeds. However, there is if you want to do some fancy cutting or you want to explore this, you could buy a router speed controller for the DeWalt, or we actually have some mounts that you could mount a different spindle so that you could have spindle control. But maybe after we walk through the different scenarios, that'll make sense to you if that's important or not. So all you really have to remember is speeds is really how fast the RPM's going. So we're at 30,000, right? And the KL7 is going to be, I think the router's at 27,000, but at least, you know, it's doable. So actually speeds is really good. The faster that you can turn that bit within the limits of the bit's capability, within the limits of the machine capability, then you should go as fast as you can. So what are those? Horsepower. You know, if you have a bigger motor, you can turn it a faster RPM and cut faster. Or if you have a big bit, right, if it's going faster, you can take more, but then you need more horsepower. So they all play together. You need the horsepower, you need the machine to be super rigid, the bit needs to be unbreakable, right? Because obviously if you turn it really fast and you're pushing it really fast, there's a point to where you're going to break a small bit, especially the 1/8 inch bits. So the RPM is fixed in our case, so really what we're going to play with is the feed rate and the depth of cut. So in cutting harder materials, as I'm learning on the Bridgeport mill, it is actually a lot better to go a lot faster feed rate with a shallow depth of cut, because you don't put as much load on the bit, and it actually turns out, if you have decent accelerations and speeds and feeds, that you can actually get around and make more passes, and it's still accurate when it cuts through and you save time.
And you're talking about, in your particular case, milling aluminum.
Absolutely, but it's the same thing on a CNC router when you're cutting wood. We start out by saying, and again, this is just a general recommendation for guys that are new, start out with about 20 inches per minute and a max depth of cut of 0.08 inches, but it actually would be better to actually maybe run it 40 inches a minute with maybe 0.03 inches max depth of cut, and then just do 2 passes. So really, since your RPM is going fast, right, we need, every time that flute, the cutting part of that bit comes along, we need it to grab so many thousandths of inches worth of material. Well, if it's really spinning fast, then your feed rate needs to go fast to get it. So
but in order to do that, in order to have that kind of feed rate, you can't be cutting 1/4 inch material, or not material. You can't be making a 1/4 inch cut.
No, your depth of cut would have to be very shallow, right? And now you can be super fast. So let's just say that, I mean, just for instance, and I don't know how well this would work, we haven't tried it on, maybe we'll try this later, but let's say that you take an E3 and you have an 1/8 inch bit that's got 2 flutes, and you've done your calculations, and it says that you should be at 60 inches a minute. And you're like, well, I don't have the horsepower or the structure to do that all at once. but if I need to be that fast because of my RPM, I'm going to go ahead and take out 15 thousandths at a time, 0.015 inches, and then I'm just going to do it multiple passes. So now your machine is screaming, right? It's moving really fast, but it's not taking out very much. So your load on the router, so you don't need the horsepower, is good. I mean, I think one of our customers, I think Chase has said this several times on the forums, is you can hear the router loading up. If you hear the router loading up, you're working it too hard and bad things are going to happen, right? The router should be just running nice and smooth. You shouldn't hear variations in RPM.
Even though you're running not a narrower, but a shallower depth of cut, with that greater speed, you're still going to get a nice, clean, accurate cut?
Absolutely.
Do you think more accurate?
Actually, I don't know about more accurate. There's obviously a balance between, I mean, you could go back to 20 inches a minute and do your 0.08 and you would get about the same amount of cut, but I think you might find that it's faster if you're zipping around and doing shallower cuts. Now when we're talking about this, we're talking about what they call slot cutting. So it's basically where the router is in just making a groove. Well, there's also step over cutting. This is where you first would take your workpiece and you would go across and you would get into the wood however deep you would want by slot cutting, and then you're just going to step over and just go back and forth, kind of like the old dot matrix printers did, right? And then it would be going up and down. Now that's a completely different story, because now you're using the side of the bit, and now it's a step over percentage. So again, if you keep that step over percentage, so every time it steps over to take out a new line, it's not doing like the whole bit, but only a small percentage, like 10% of the bit, then you can run at 100 or 120 inches a minute.
Oh, okay, I got you.
So yeah, so there's two different types of cutting. Now for us, and you guys have probably seen the video already, we're cutting out with the KL755, we're cutting out the 44 and the 33. And at first we were trying to do it in 2 passes, and we were successful. We could do it in 2 passes at basically a 1/4 inch, running at 50 inches per minute.
Right.
But our bits got hot and turned black. So I was reading online and, actually did some calculations, and it's like, holy cow, that's way too slow. We really need to be moved up. So it's like, well, there's no way in the world at 250 inches a minute I could take out a 1/4, I'd break the bit, right? So if I'm going 5 times as fast, maybe I'll cut only in 4 passes and save some time. And man, that router screams as you watch the video, but the cuts come out just as clean, and now my bits are lasting longer. And I guess that's probably the final thing that maybe we could leave you with. If you get the speeds and feeds right, your bits don't turn black, and you don't
see a lot of smoking?
Not a lot of smoking. Well, we never saw the smoking, but as Ashley came back there and says, smells like popcorn here.
That's right.
Right, yeah,
That's
so there was heat there, and it was burning the wood, but you didn't see the black on the wood, but you could sure see the black on the bit.
Right.
So yeah, faster cutting, or feeds, right, because you have a high RPM, and shallower depths of cut may turn out to be a lot better way of going about the CNC. So if you look at your standard defaults in your Vectric software, they're going to be for production machines. You need to adjust those for the machine that you have, and give it a shot. So that's what we have really for speeds and features. That's all I know. Not very much, I know, but
it's more than me.
Okay.
Don't even ask me questions. Well, guys, if you have any questions, be sure to get a hold of us at the help desk at bobcnc.com. Did I say it right this time?
Not really. It said shop talk at bobcnc.com.
Did I do it again?
Yeah, you did. But we're going to leave it
I'm
this
going to
time.
give them Kristen's email.
There you go. Hey, for you guys that have expertise in this area, please post your recommended settings for the type of project. Maybe show the type of project you're doing and saying, hey, I'm running at this depth of cut, at this RPM. I do have a speed controller. I don't have a speed controller. That would be awesome.
All right, till next time. Thanks so much.